Approaching Neptune, after 12 years on the road and another billion miles, Voyager 2 was an exhausted traveler. By August of 1989, Voyager 2 was speeding more than 40,000 miles per hour toward its rendezvous with Neptune, the last stop on its spectacular grand tour of the 4 outer planets. Discovered in 1846, Neptune was named after the mythical Roman god of the sea. The planet appears blue because its methane absorbs most of the red in the spectrum, leaving mostly green and blue. Voyager 2 flew by Neptune only 22 miles off its charted course, and only 1 second off its scheduled flyby time. Skimming only 3,000 miles over the planet's north pole, Voyager found Neptune to be a giant ball of melted rock and ice, cloaked in hydrogen, helium, and methane gases, its atmosphere whipped by winds of up to 700 miles per hour. Voyager flew the closest that any spacecraft has come to one of the outer planets, discovering at least 4 complete rings of ice and rock, 6 new moons, and a great dark spot, a hurricane the size of Earth raging in Neptune's southern hemisphere. Dr. Andrew Ingersoll.
The storm revolves around the planet every 18 hours, and then it rotates around its own axis like a big glob of pizza dough every 16 days.
Largest of Neptune's 8 moons, Triton orbits in an opposite rotation from the planet. Triton was once probably an independent object in orbit around the Sun, until it collided with a moon and was captured by Neptune's gravity. Pockmarked by impact craters and glazed pink by a radiation blitz of methane and nitrogen ices and atmosphere, Triton is the coldest known object in the solar system and one of the most reflective. Utilizing Voyager's digitized photographs of this icy moon, scientists saw jagged mountains, high cliffs, and frozen lakes. The most bizarre discovery on Triton was the presence of icy geysers, some of which are still active, spewing organic particles 100 miles downwind. Dr. Edward Stone.
The Voyager mission to the outer planets has certainly been a journey of a lifetime. Having encountered Triton as the last world we would visit, I don't see how any of the scientists could have been happier.
Voyager 2 has set its course for southwest of the constellation Sagittarius. Traveling at 10 miles per second, it is expected to pass 4 light-years from Sirius, the brightest star in the heavens, 290,000 years from now.
NASA's Kepler telescope trails behind Earth in its orbit. Since 2014, Kepler has been looking outward along the ecliptic, the plane of our solar system. In this orientation, the telescope can observe the superior planets like Neptune, which passed through its field of view in late 2014 through early 2015. As we zoom in to Kepler's array of detectors, we see the images taken by the telescope during this period, sped up from over 2 months of observations into a matter of seconds. The dot orbiting Neptune is its largest moon, Triton, while the smaller moon Nereid trails faintly to the east. About halfway through the observation, Neptune appears to stop its westward march and reverse course. In reality, Neptune always moves east, but at a slower rate than Kepler. This causes an apparent retrograde motion, or backward step, each time that the telescope laps the planet. The Kepler telescope was originally designed to search for planets in other solar systems using the transit method. When a planet passes in front of its star, it causes a small dip in starlight that can be measured by Kepler's sensitive detector, revealing the presence and size of the planet. During the Neptune observations, Kepler instead looked at changes in reflected sunlight. It measured fluctuations in Neptune's brightness of less than a single percent, caused by factors including the planet's daily rotation, the movement of clouds, and even seismic waves within the Sun itself. By measuring tiny variations in Neptune's brightness, Kepler teased out clues to the planet's hidden dynamics, pushing the limits of its detector and laying the groundwork for more detailed studies of exoplanets in the years ahead.